Good afternoon, everyone. My name is Tanya Cochran, and I am a marine mammal researcher with Unity Environmental University. Today, I will be presenting a hypothesis regarding a major conservation crisis, the mass stranding of over 100 long-fin pilot whales in the Chatham Islands, New Zealand. This event demands our attention, and through understanding the species and the environment, we can better hypothesize the cause. To begin, let's define what a stranding is. Any marine mammal found on land and unable to return to the water is referred to as a stranded organism. Strandings can occur as single events where one individual is affected, or a mass stranding event where an entire social group comes ashore. For researchers, it is often challenging to pinpoint a clear cause, as many different factors can contribute. Our focus today is a mass stranding event of over 100 longfin pilot whales reported on the remote Chatham Islands. As toothed whales, pilot whales are experts in navigation through echolocation. They emit clicks and interpret the returning echoes to form a spatial map of their environment, telling them the distance, size, and speed of objects like prey or the seafloor. However, this is a critical point. Their system is highly optimized for deep water. When they move into shallow, gently sloping coasts like those found around the Chatham Islands, the echolocation system fails because the sound signals become confusing and weak, leading to distortion. Long-finned pilot whales are cosmopolitan, preferring deep, cool ocean waters, and are a well-documented species in the waters off New Zealand. Their movement is primarily driven by the search for food, mainly squid, which often takes them on a deep dives and into different currents. But the most important factor here is their social structure. They live in highly cohesive, stable pods with incredibly strong family bonds. This loyalty means that if a leader or a single whale becomes disoriented or distressed and swims toward the shore, the entire pod will follow them. This social loyalty is the mechanism that turns into a single stranding incident into a mass stranding event of over 100 animals. Long-fin pilot whales are found globally in deep, cooler waters. They have a known about significant presence off the coast of New Zealand. They live incredibly tight-knit, stable, and highly cohesive family units or pods. Their strong social bonds are a defining characteristic. Their movement is primarily driven by the search for their main source of food, which is squid. They are typically offshore animals, often diving deep to forage. The Chatham Islands are a remote archipelago located about 800 kilometers east of New Zealand's mainland. This location is geographically significant. The island's shelf is shallow, and the beaches often feature a very gentle, gradual slope, a feature we know contributes to stranding risks. Now, for the core of the hypothesis, the primary cause is likely the failure of their navigational system within the Chatham Islands environment. In a shallow, gentle sloping environment, echolocation fails. The gradual slope doesn't provide a clear, strong echo signal, causing the whale to become disoriented and lose the ability to detect the coastline. Furthermore, the Chatham Islands topography creates natural whale traps, exacerbated by rapid tidal changes that can leave disoriented whales stranded very quickly. Why a mass stranding? This is explained by their strong behavioral traits. Pilot whales possess strong social bonds, causing entire pods to follow distressed individuals. If a sick leader or a disoriented member of the pod swims into the coastal trap, the rest of the pod will not abandon them, but will follow them ashore, leading to the devastating mass stranding event we are discussing. While environmental and social factors are a key, we also consider compounding factors. There is a research suggesting that geomagnetic navigation disruption may compound echolocation failures during strandings. Whales may use the Earth's magnetic field lines to navigate. When these lines intersect with the coast in unusual ways, it can confuse the whales and push them towards the shallow slope, amplifying the risk created by the echolocation failure. In summary, the mass strandings of long-fin pilot whales in the Chatham Islands is not due to a single cause, but a combination of two major factors working together. First, the environmental failure. The topography of the Chatham Islands causes the whale's advanced echolocation system to fail, leading to mass disorientation. And second, the behavioral factor. The species' extreme social loyalty ensures that when one distressed whale gets trapped, the entire pod follows, leading to the mass stranding of over 100 animals. Moving forward, the scientific community should focus on enhanced satellite monitoring of pilot whale migration routes and the development of rapid response protocols specifically tailored for stranding hotspots like the Chatham Islands. And I want to thank you for listening to my presentation. I hope this was interesting.